JavaScript numbers. We'll be looking at more in depth with numbers here. Okay, so the previous video we'll learn more about strings, and this time around we'll be jumping to numbers. So let's dive deep. So we'll be having some examples to understand all kinds of numbers in JavaScript. Okay, so let's say we have L with a variable of x, and then we want to declare a variable. It's very easy. Variables, we want to declare an integer, and the integers are just single numbers or whole numbers. So for example, 2 is what? 2 is simply what? An integer. So then let's say we have another variable and then another. So let's have y here, and then let's have a z here. Okay, so the second one, we want to declare a floating number, and then the third one, I want to declare hexadecimal. So hexadecimal in JavaScript. So floating number simply means double figures. For example, we could have 2.13. It's a floating. And then we could have hexadecimal of 0xFF. We can find hexadecimal numbers online when we search in Google. Go. So let's look at this. So we have all these kind of numbers you can use in JavaScript. So let's just display this real quick and then see what we got on the screen. So we have x here, which is an integer. So x is an integer in here. Let me add spacing in here. So concatenate, and then we have okay, so I want to print the 3 of them. So the first one, the second one is y, and then the last one is z. Okay, so let's refresh. So we have 255 for the hexadecimal, which is not commonly used, so we can search for all hexadecimals on Google, and then we'll find a lot of code which represent that. And then we have a floating and an integer. So let's look at other numbers, and we'll look at numbers as exponential. So let's check exponentials in Java. So here, let's say we want to have the first one, we want to have a number of let's say 15,700. so 15,700 in exponential will be 1.57 exponential 4. So now let's say we want to have maybe a number around, let's say let's go into about having, let's say 6 zeros rather. So let me type just a random number. So let's say 0, 0, 0, 0. So we have, so we have 6 zeros in here. Okay, so how do we write this? Is very easy. We need to just start with the first 4 dots, then we'll add the second numbers, which is 25 here, 25, and then we'll add the e, which is exponential, then we'll add plus 6. So it's actually 6 digits when we look at this side. And we can also have a number like, let's say we want to show a number like the opposite of this. So let's have something like 0.12345. Then we have 425. Let's do this. 425. So the exponential for this will simply be the same for this one, but the only changes here is gonna be the minus. So instead to put a plus here, we put a minus because the zero stat in front. Okay, let's print this on the screen. Let's see. So exactly what we had was 15,700. We have the 5,50,000. So 400 and 250,000. Then we have the 0.000452. So these are the ways we can easily implement exponents in JavaScript. Okay, so let's say we want to represent more hexadecimals. For example, the first one we tried something simple, but let's say we want to do something like a hexadecimal for 180. So 180 here will be OXB4. So OXB4, and like I said, you could find most of the hexadecimals online, and it's pretty easy to do that in JavaScript. So let's look at adding numbers and strings. So let's move on to numbers and strings together. Okay, so adding those numbers together. So we already learned how to add numbers in our previous video, and we can add numbers just by using their variables. So for example, we can have separate numbers here we can use. So let's say we have a 10 here, we have a 20 here, and then we have a 30 here. So yeah, so if we want to add any of the numbers, we can simply call it a variable. For example, here we can have x and y. So let me do x and y here. So x and y should give us a 30. So we have x here, which is 10, and y, which is what? Which is 20. Then it gives us a 30 there. This is printing the variables we have assigned to it. So that is how we can actually add numbers in there. But let's see, adding a string with a string, and then this string, for example, if we have this 30 inside a double quote or inside a quote, and then we print out x plus x, it's z plus z. Let's see what we'll get on the screen. So z plus z will not give us 60, it's gonna give us 2 30s. Why? Because it's actually looking at it as a string instead of a number. So anytime we want to add, we want to simply what? Simply leave the numbers unquoted. If we have it in a quote, it's gonna act as if it's a string. So for example, if we want to add the one which has no quote and the one with quote, so we try that here. Let's say y is equal to 20, which is not in a quote, and then z, which is inside a quote, and let's see what happens. So because this is not in a quote but this is in a quote, it's treating one as a string, and then we cannot add a string to what? A number. So that is what it's actually going to give us here. So we can add almost everything here we got, and then see. So let's see, we want to add x, we want to add x here, then we'll add z here. No, we have z at the beginning, so we add x. Okay, so this is what we get. We get 30, 10, and 20 because of just one string, which is actually inside the variable. So it's gonna make all those values looks like a string in JavaScript. So that is how this works. So let's look at how we can divide some of these numbers. So if we have x and y, we can simply use the division, which means x is 10, y is 20, and then let's see what happened. We have the 0.5 there. So we can use division here to divide any number, and then we can use multiplication also here like this. So we have 200, and then we can use a division, and then we get minus 10 because x is 10 and then y is actually a 20. So that means we're gonna have a different result for that, because the 20 is the last one and the 10 is the first one. Okay, so let's see, we want to perform a mathematical operation on non-numeric numbers. So let's say we want to perform mathematical operations on non-numeric. So for example, we have 10 here, and then let's say we have a 4 in here. So 4, and we have a num here, which is none. So let's say we have a num here, and with the num, what we get to do is let's try if we want to do a subtraction on one which has a none and one which has a 4. So the x here, let me do this real quick. So we have the y, which is a 4, and then we divide it with a z, which is a none, and let's see the result we're going to get on the screen. So we have it to be none, because we can add that together. So let's see if we want to add, even here, if we look at a z here, and then we have an x here, which is 10, and then we have a y here, which is none, which is the last one. It displays only the none and the 4, and then this is none plus none equal to none, and then 4 plus none equal to 4 none. So this is how it actually looks like. So even if we have a division for both, nothing happens on it. So we can not actually be adding non-numeric to a numeric number. Okay, great. So let's look at adding floating numbers in JavaScript. So floating numbers, and looking at floating numbers, we can say we're gonna have 2 of this here. Let's say x is equal to 0.5, and then we have a plus, and then we do a 0.3 here. Here we can simply print this out, which is a document .write, and then print this 2. No, let me do this and then call x in here. Then let's see. Okay, so this is adding these two float. There's 0.5 and then 0.8. So it's gonna be a 0.8. So let's look at checking a run up. This, if we want to check fixing a run off error, and for example, if we want to add a whole lot of figures, we can simply divide all these by a bigger number, and it will still return a float, which is going to be a 2 decimal number. So for example, if we want to have a division, we need to put this inside a round bracket, and then let's say we want to divide this by 10. So let me add something like this times 10 here. So 0.5 times 10 plus 0.2 times 10, no, times 0.3. So let me put a 10 here. So then we display this on the screen. This simply gives us 0.7, and this is only displaying a float, and it's not giving us actually too many zeros. So it's only displaying a 2 figure, which is the 0 and then the 0.7. So that means it's kind of not adding too many zeros to what we get on the screen. Yeah, so let's see if we can have other precisions in here, especially if we have a very long number, and then we see what it's gonna float, it's gonna print on the screen. So let's say we have the precision problem with the integers. So we go with precision problem with integers. Okay, so with the precision problems, we need to assign a variable which is x to a very large number. For example, we're gonna have plenty of 9s here, and with the plenty of 9s, let's see how this is gonna show on the screen. Exactly what we have here is what is going to show on the screen. So any number which is actually in the integer format is going to show in the integer way. Great. So we can parse integers from strings, especially if we want to show only the whole digit and then ignore any other digit that follows a specific number. We can use what we call the parseInt. Means it's going to convert every number we have here into an integer. So let's look at something like printing out. Let me comment this, and let's say we want to print something out here using the parse integer. So with the parse, it goes like this: parseInt, and then inside here it's going to be a string, and it's a number, but since we're going to have a double quote around it, this it's going to treat it like a string, and then it will print only the first real number inside this. So for example, if we have 3.4 in here, it's gonna print only 3 because it's converting this whole thing in here into an integer. And let's look at the next one. We have, like, for example, if we're gonna have something like a 50 pixel here, a 50 pixel, and then we'll print that to the screen. It gives us 3 and 50. Okay, we don't have a break here, so it's a little bit confusing. Let me add a break here. Okay, then I print it out. So the second one, we have what, 50, and it's actually ignoring the what, the pixels behind it, because we are converting the whole thing into an integer. So let's have another example on this line. So here, let's say we have another, let's say a 20 TT, and then let's say we have another one with a hexadecimal and then a number. So let's see, we have a hexadecimal of 0x, what we just used a few minutes ago, 0xFF, and then we have an integer attached to it, so 16. And let's see what we're gonna get. So now we having this 20 PT is coming out to be 20, and for this one it's converting only the string to an integer and then ignoring this one. So this is how it actually works when we use the parse integer. Let's look at this. What if we have something like 30 years, and let's see what comes out. It only comes up with the integer because we are converting, we are only converting to integer here, so we don't print anything string on the screen. Okay, so what if we have something like this? For example, we have the year coming first, and then we have 2024. Which one do you think it will print? It's gonna print a 9. Why? Because it's picking only the first string inside what we have here, and then just like what it happened here, it picked only the first string and it left this one out. So that is how this parse actually works. So what if we have many strings in here? Let's say a 19, a 10, and then a 20, and maybe 2010. Let's see what happens. It's still gonna print the first one, which is the 19. So looking at JavaScript parse integer from string, that is how it actually operates. So we need to always bear in mind that this is how these parses actually operate. So let's look at, okay, the next one. Let's look at parse in floating numbers. So instead to use an integer here, we can simply use a float. So this will convert everything in there into a float. So let me store this and reload. So first we're having only 3, but now it brings out the following dot numbers. So for 50, when we have, let me add a parseFloat to all. This one here, that, and let's see what it will print on the screen. And then we have this. Okay, now let's reload. Now we have all the numbers coming out correctly, and then it's leaving out the year to still none. So every parse converts the first part of it, and then leaves the rest. So this, it convert the 19 to an integer, because float can have both integer and then float in between. So that is how it is. But what if we have something here like 3.14 here? Let's see what happens following that. It still prints the same float and leaves the string there. Okay, great. So now let's look at converting numbers to string. So numbers to string. So here numbers to string is kind of converting numbers into a simple string. But let's look at example of this. When we have a number, for example, number 12, and we do 2.string, it's still going to print the 12 out. Let's look at this. Let's say we have 10 here, and then we say we let our variable be equal to y, and y be equal to our x dot to string. Great. And let's print out our y here, and let's see what happens on the screen. It gives us a 10. So even though we're trying to convert this number to a string, it does not. It still gives us what? It still gives us the same number we have stored in x, and it does not convert it to a string. So what if we want to find the type of x and y? So for example, if we say document dot write, but this time around we're gonna do type of, even though it's actually giving us 10 on the screen, inside the Java memory it's still seeing it as a string, because we have done dot to string. So but on the screen it's just giving us what? It's just giving us the actual number. So let's see what prints here. So it prints string. Okay, so let's see, I comment this one. It prints what? String. But this is the type of, so the type of y is string. What about the type of x? Let's see. Type of x will give us a number. Gives us a number. So x is actually a number, but since we have x being converted to string and stored it in y, it gives us a string. So technically it's a converted string, but visually it's still giving us what? The same 10 that we have. Okay, so let's see this. Now let's look at something else, and let's try to convert some numbers to exponential. First, we were writing the exponential right from our head, right? So let's say this is converting numbers to exponents. So simply exponential numbers. Okay, so for example, if we have x, if we have x equal to, let's say, 10.1234, yeah, just a little bit like that, and then we want to convert this, is very simple. We just have to call the variable assigned to it, and then we'll add dot to exponential. We need to have round brackets in front. Then we convert this whole number to what? Exponential. So this is how we can have our JavaScript convert all our numbers to exponential if we need that in the future. So let's look at formatting numbers in JavaScript to a decimal place. And then so we can have fixed decimal place, and then we can convert it based on the number at which we want it to show. For decimal place, we have numbers like 1.123, and we can have 1.1. So depending on the number of decimal place we want to show on the screen, we can specify that in JavaScript. So let's say this is what? Performing a fixed decimal places on numbers in JavaScript. So let's still use the same 10.0, but this time around we want to convert it to a fix. So to a fixed decimal place, if we use what we call toFixed for this one, we're gonna get only 10 and then ignore the rest. So this can apply to many numbers we have in our program. For example, if you have pricing which have 0.999 or something in e-commerce, with this you can simply convert every decimal into a whole number. So what if we just want to display just one or two of these decimal numbers? This is pretty easy. We just have to put a number in here. So for example, if we want to show 1, we put 1 in there, and then it comes 10.2. What if we want to do 2? We just put 2 here, and then it goes 10.12. So that is how we can easily do that. But don't forget, if we have a hexadecimal number, for example like this, let's say 6.25, then we say, no, I'm talking about exponential. So exponential plus 5, and then we want to convert this into what? A fixed decimal number. We just have to convert this one. This one is going to give us 5 zeros, but if we have 2 here, or let me take this one out first, and we see what it prints on the screen, which is 625000. Then now we want to reduce the exponent instead of 5 to 2, so I put 2 in here, and then we reload. So the decimal, we're gonna have a decimal place of what? This 5 here, but it had no decimal place behind it, which means there was nothing here. But when I added a 2, it added 0.00 here. So we can manipulate this by using different numbers in here. So if I put 1, then it's gonna have this 1 in here for us. So this is a very easy way of formatting numbers in the decimal places. And let's see if we want to try a precision. So instead of toFixed, we can simply use toPrecision. and then let me see. To precision, let's have a floating number here, then a 6, then let me clear this, then we reload, we have 6.56, that is to precision. So format numbers with precision, so we can have the same as the fixed, where we can have 2 here, and then 2 also shows us only 6.3, but we can also use to precision to also convert some numbers to numbers to this exponential. For example, if we have, let's say 1 2 3 4 but 5, and we want to say to precision, this one will convert to 1.2 exponent. So this is how precision also works on numbers. So any of these functions or JavaScript provided functions or object do have its ways of applying its object to numbers we want to use in the future. So let's say if we want to simply have the largest and the smallest possibly of a number. So for example, we have JavaScript largest and smallest possible numbers, that is number.max value, number.mean value, and then number.mean value times a number. So for example, if we want to have x be equal to number dot max value, so this one is gonna print maximum number just on the screen for us. So here, instead to do precision, it takes out precision here, and then I print out only the x. Then let's see what happens. Because of this number dot precision, so largest to smallest, don't forget, we are just checking how to print largest and smallest numbers, possible numbers. So this function here will help you print numbers just randomly to the max. Okay, so let's have still the same, so it's not with the variable, it's because of this function we are using here. Was just trying to demonstrate something. And then we can have numbers to the minimum value. So instead of the max, we can just change minimum here.